Welcome, my dear students, and we are going to discuss these functions from basic level to the problematic part, such that it will helpful to you, right? First of all, a function. What do you mean by a function? Like a function definition, like a function is a special kind of relation. Of course, a function is a special kind of relation, such that we have it will satisfy certain conditions. Like, okay, it is a relation. Okay, let f is a relation. First of all, from A to B. Okay, it is a relation with some additional condition, such that here this is such that each and every element, right, each and every element, right, each and every element in the domain A has a unique corresponding element. Unique corresponding element. In B, like it has a unique corresponding element in B, right? F is a function from A to B such that each and every element in the domain A has a unique corresponding element in domain B, like this, right? Fine. Fine. This is what we have here now. See, this is what we have here. Here, the 2 points are important. Each and every element in the domain A, okay, in the domain A has a unique. Unique means only one corresponding element in B, right? Only one corresponding element in B. This is what most important, like this, right? Okay. Then how we will be doing this particular problem? This means, suppose you see, we are going to observe some examples like this. A, B we have here like this. F is a function. If we say that, suppose I am having here 1, 2, 3, 4, A, B, C, like this. 1 with A, 2 with B, 3 with C. I am having like this. Is it a function? Is it a function means no, because we told that each and every element in the domain A, here this is called, A is called domain, B is called codomain, like this, right? This is not a function, because each and every element in the domain should have the correspondence. Here 4 is not at all got mapped. It is not having the correspondence. That's why it is not a function. Next, what we have is here like this. A and B we have, and F is a thing like this. Now 1, 2, 3, 4 like this. I am having here. I am having A, B, C, D, E. See this example, how we are going to have 1 with A, 2 with B, 3 with C, 4 with D, 1 with E, like this. Is it a function? No, because what, each and every element in the domain has a unique. Here unique means what? Only one. We should have only one corresponding element. But here 1 is corresponded with A, 1 is corresponded with E. Therefore this is also not a function, like this. Therefore this is also not a function, like this. Okay, fine. Next, you see here we have A, B like this, right? A and B like this. I am having like this 1, 2, 3, 4 and A, B, C, D like this. 1 with D, 2 with A, 3 with B, 4 with C. Is it a function? Yes, it is a function, because each and every element in the domain A has a unique one corresponding element like this. Therefore, it is a function, no doubt in it. Now we have here another thing. Suppose Okay, I'm having here 1, 2, 3, 4, A, B, C like this. 1 is corresponded with A, 2 with A, 3 with A, 4 with A. Is it a function means? Yes, it is a function. Each and every element in the domain is corresponded with a element. Only one element in A. Even that may be the same, no problem also. And one more thing I want to tell you, the physical example of a function is, for example, if you take a book, each page will have one number only like that. That is a best example of a function. Okay, every page in a book will have one unique page number. One page will not have two different page numbers. That is a best example of a function. And second one is, if you go to the supermarket and for buying of any groceries or anything, okay, you are going to pay only one price for any one article. There may be, for example, for 10 rupees, there may be one pencil, one pen, one book, one chocolate. But you have to pay only one price. Here also, okay, many articles may have same price, but you are going to pay only one price for each article. That is the best example of a function, right? Now, you see, whenever we are having a function like this, okay, set A, I am having the domain and B is the codomain like this. F like this, 1, 2, 3, 4, we have here A, B, C like this, right? Once we have the thing like this, suppose 1 is corresponded with A, 2 with B, 3 with B, 4 with C like this. Here the domain is equal to A like this. That means you have 1, 2, 3, 4 and codomain is equal to B. That is nothing but A, B, C like this, right? And range, here the range is nothing but A comma B like this, right? The elements which are got corresponded, that is what you call the range. Here domain, codomain and range. And one thing you can observe, that range is always subset of codomain, like, because within the codomain elements only we are going, that function is going to map like this. Range is subset of codomain, right, my dear students, like this. And here one more thing you have to understand here. Okay, we have here f of 1 is equal to A, right, and these are called A, B. Okay, f of 2 equal to B, f of 3 equal to B, f of 4 is equal to B. These are what they are f images of 1, 2, 3, 4. Here A comma B are the f images. Therefore, okay, f images of 1, 2, 3, 4 is nothing but, here we have got A comma B like this. F images, what we call here, of course. Now, when f is a function like this and a function or relation, okay, f inverse is a function or a relation from B to A, we know that, of course. Every function is a relation, but every relation may or may not be a function like this. Therefore, now you see here f inverse of A is equal to 1. You have here now f inverse of B is equal to, you got mapped here with the 2, 3, 4 like this. F inverse of B equal to 2, 3, 4. Therefore, see here, you see, my dear students, these 1, 2, 3, 4 are called as pre-images, like pre-images, right? Now you see here, 1 is the pre-image of A like this, and 2, 3, 4 are the pre-images of B like this. Okay, these are called now 1, 2, 3, 4 are the pre-images, right, of pre-images of A comma B like this. This is what now we have understood in this, what is domain, what is codomain, range, and range is always subset of codomain, and what you mean by image and what you mean by pre-image. These things are very, very important. Next we have graphical testing of a function. If you take, my students, any one graph, for example, okay, a graph of a function, for example, this is a circle, something like this we have here, of course. Okay, will it represent a function? Okay, this graph will represent a function means, okay, what is the test for this is vertical line test. Like, what is vertical line test? If you draw any line parallel to y-axis like this is what y-axis here, vertical line. If it cuts the curve at more than one point, suppose I have here x1 here, this is now y1 and this is y2. That means we have here x1 comma y1 and x1 comma y2 like this. If it cuts at more than one point, then it will not be a function. It will not be a function, because for one x value you are having two corresponding y value. We told that function means it should have a unique correspondence. That means only one value should be correspondent. That's why it is not a function like this. Suppose if you take another thing like this, if you take this like this, and if you draw a vertical line here also. Here also it is cutting at 2 points like this. Therefore, it is not a function like this. Right, my dear students? Next, if you take one more thing like this. Suppose I have here like this, like this, like this, something like this. Right? Here also, if we observe that, if I draw a vertical line, it will coincide with this vertical line like this. It will coincide with this vertical line. And this will have commonly infinite number of points like this. Okay, if we have infinite number of points, means this is also not a function. Okay, because one x value you are having infinite number of y values like this. And next, if you take here, suppose I am having a function like this, right? Fine. Now this is a function, because if I draw a vertical line, it will intersects at a single point. Therefore, it is a function like this. Next, what we have here is, okay, like this I am having here. What about this? This is also a function, right? If I draw a vertical line, it cuts at single point like that. Now, if you draw a upward parabola like this, will it represent a function? Means yes. If I draw anywhere a vertical line parallel to y-axis, it will cut this at a single point. Therefore, this is also a function. This is a function. This is a function. This is a function. Like this we have here, right? Next, we have number of functions. My dear students, you see here number of functions. How we are going to do this one, like number of functions. See, this number of functions means, for example, I am having here like this. Okay, 1, 2. I am having a, b like this. Now, how many functions I can define? Set A is domain, B is codomain. I am having here like this, 1 with B, 2 with A. This is one function I am having here. Next, we have here 1, 2, AB like this, 1A, 2B. This is another function we are having here. Next, what we have is 1, 2, AB like this, 1A, 2A. This is also another function we have here. Therefore, here also 1, 2, AB. That means 1B, 2B. This. Totally we have 4 functions, that means. Therefore, the total number of functions we can get a nice thing. Here we have here totally 4 functions here, of course. Okay, 4 functions. That means when we have here, okay, therefore the total number of functions is nothing but n of b whole power n of a like this. N of b whole power n of a. That means 2 square here. A is having, okay, here n of a is equal to, you know that n of a is equal to 2. And n of b is also equal to 2 like this. That is now 2 square, that equal to 4 functions you have here like this. Okay, the number of functions, what is that? 2 square, that equal to 4 like. Fine. Now we have set A equal to 1 to B equal to ABC. The number of functions we are going to get actually 9. Let us write all of them, right? What are those? 1 with A, 2 with B. Like this is one function we have here. Next, 1, 2, ABC like this. 1 with B, 2 with C. This is another one we have here like this. Now this is 1, 2, ABC like this. 1 with A, 2 with C. This is what we have, another thing. Next, you see 1, 2, ABC like right. 2 with A, 1 with B. This is another kind of function, right? Next, 1, 2, ABC we have here. 1 with C, 2 with B, we have another function this, right? 2 with B, 1 with C, like this, another kind of function. Next, we have here 1, 2, ABC like this, right? Fine. 2 with C, 1 with B like this. That is already given, that 1, 2 with C, 1 with B, that is already given. See here we have here 2 with A, 1 with C, and this one 1A, 2A, this is 1B, 2B, this is 1C, 2C. Totally we have here total number of functions is equal to now total number of functions that is equal to, we have here n of b whole power n of a like that means 3 square, that means 9. We have totally 9 different functions, right? Now see, my dear students, we have here equal functions. Equal functions are identical functions. The next one we have here, equal functions are identical functions. When two functions are equal or identical means, okay, you see here they should have, see my dear students, first of all, if f and z are two equal functions, like if f and z are two equal functions, they are equal functions, then f and z should have same domain, like this, they should have same domain, both functions should have, that means domain of f should equal to domain of z, like this, domain of z. Number 2, the condition is range of f should equal to range of g, like this. That means what we have is f of x is equal to g of x, like for all x belongs to the common domain, okay, domain of f and z, like this, domain of f and z. This is what we have here, like this. Now we have here on problem, basic level problems, we have here which of the following correspondence can be called a function, like this. Option A, okay, this is what A, we have here f of x equal to x cube, okay, this is the function rule we have given. -1, this is what domain, okay, this is what domain we have here, and this is what codomain, like this, like this, right, codomain, right. Suppose if I take -1, now -1 whole cube is -1, that is not present in codomain, therefore it is not a function, first itself we can see. Now f of x equal to plus or minus root x, we have here like this, 0, root over 0 is 0, okay, fine, right, 1, plus or minus 1, like this, okay, 1 if you take here, you are having here what, right, here when we take f of x equal to plus or minus root x, if I take for example x as 1, now f of 1 equal to plus or minus of root 1, that is now plus or minus 1, like this. That means one element, even f of, if I going to take 4, this is now plus or minus of root 4, that is plus or minus of 2. That means 1 is corresponded with 2 elements, like this. You see here 1 is corresponded with here, okay, 1 minus 1, like this, okay, 1 should not correspond with more than one element, therefore it is also not a function according to my knowledge, like, see here, this, you have here now 4, here also plus 2 and minus 2, that should not be there, like this, therefore it is not a function. Next, if you take this one, now f of x equal to root x, you take now 0, root over 0 is 0, root over 1 is what, 1, yes, that is a function, root over 4 is 2, this is a function, no doubt in it. And here also f of x equal to minus of root x, right, if you take f of x equal to minus of root 0, that is 0, f of x equal to minus of root 1, that become, okay, minus 1, f of x equal to minus of root over 4, that equal to minus 2, this is also a function, like this, yes, wonderful, this is also a function, no doubt in it. In this way we can easily understand which is a function, which is not a function from this basic problem. Okay, now we have this problem, right, f of g of x be a function defined on -1 to 1 if the area of the equilateral triangle with two of its vertices at 0, 0 and x, g of x is root 3 by 4 square units, then the function g of x is equal to what? This is what now equilateral triangle, my dear students, a 0, 0, b x, g of x, see something like this. Area of a equilateral triangle, we know that this is nothing but root 3 by 4 side square. Side is nothing but AB square we have here now. AB equal to root over, this is what now, x minus 0 whole square plus g of x minus 0 whole square. That means square root of x square plus g of x whole square. Like that means AB square we have here. If you do squaring on both sides, x square plus g of x whole square, like this. And okay, now the area of equilateral triangle is nothing but root 3 by 4 AB square. AB square we have got x square plus g of x whole square. That is given it as root 3 by 4, like this. Now this root 3 by 4, root 3 by 4 cancels. Now x square plus g of x whole square is equal to 1. Now g of x whole square equal to 1 minus x square, and g of x equal to root over 1 minus x square, right? This is what g of x function. Okay, and sometimes even we can say that g of x is equal to plus or minus root over 1 minus x square also we can say like this, right? In this way we will be getting the g of x function, right? G of x is equal to, this is the thing we have. Now we have one important thing, operations on real functions, my dear students. Before going to that, we have to define three definitions. One is real variable function. What do you mean by real variable functions? Here they given that real function. That's why we have to define number one, real variable function. What do you mean by real variable function? Means if f is a function from a to b, like that. If the domain is subset of real numbers, the domain is subset of real numbers, then f is called, okay, then f is called real variable function. Real variable function, like this. Real variable function, right? This. Next, you have here a real valued function. Real valued function, right? What do you mean by real valued function? Means if f is a function from a to b and the codomain is subset of real numbers here. The codomain is subset of real numbers, then f is called real valued function. Real valued function, like this, right? Fine. Next, the third one we have here a real function. Real function, right? What do you mean by this real function? Means if f is a function from a to b, right, and a is subset of r and b is subset of r, right, then f is called real function. Both domain and codomain are subset of real numbers. Then f is called a real function, like this. F is called a real function, right? These are basic. That's why real functions means here the domain and codomain both are subsets of the real numbers. Such functions are called real functions. Now operations on real functions we have here. If otherwise let f and z are two real functions. F and z are two real functions, right? That means domain and codomain are both subset of real numbers. F and g are two real functions such that f is having domain. F is having domain, right? D1, like D1, right? F is having domain. Okay, like let us write here like this. Domain D1, like this, right? D1, right? And G is having domain, right? Here G is having domain D2, and codomain may be anything, like that. Means f is a function from D1 to some real numbers, and G is a function from D2 to real numbers. Like these are two functions having domain D1 and domain D2. Now how they define the sum of two functions, like f plus g of x. This is what we call f plus g of x. Is how it is defined is f of x plus g of x. This is defined as for all x belongs to the common domain of see, this is what f plus g of x, common domain of f and g. That means x belongs to D1 intersection D2, like this. X belongs to D1 intersection D2. And in the same way f minus g of x, how it is defined is f of x minus g of x for all x belongs to D1 intersection D2, like this. Number 3, f into g of x, how it is defined is f of x into g of x, like this. For all x belongs to D1 intersection D2. Next, f by g of x, how it is defined is nothing but f of x by g of x. Okay, for all x belongs to D1 intersection D2, such that g of x, the denominator should not be equal to 0, like this, right? Fine. F by g of x is defined like this. And some other we have here, suppose we have, okay, the fifth one, the scalar, okay, some constant k is there, k plus f of x, some constant function. This can be written as k plus f of x for all x belongs to d1, like this. Here k is a constant and k belongs to r, like k is a constant, like scalar quantity is added, then it becomes like this. And one more thing here, my dear students, the sixth one what we have here is k into f of x, like this. K into f of x, if you take here, this is nothing but k times of f of x for all x belongs to r, and k is okay, for all x belongs to d1 and k belongs to r, real numbers, like this, right? This is what the sixth one. And the seventh one what we have here, like, right? Suppose if we have f power n of x, this is equal to, right, f of x whole power n for all x belongs to domain d1, like this. For all x belongs to domain d1, f power n of x equal to f of x whole power n for all x belongs to d1, domain d1, right? Now see, my dear students, this is one interesting problem. They given f is 4, 5, 5, 6, 6, minus 4, and g is given like this. So now we require to find all these things, like, okay, g is a function given like this. Now see how we do this part, like they given that f of 4 is equal to 5, right? And they given f of 5 is equal to 6, right? And f of 6 is equal to minus 4, like this. Next, g of 4 is equal to minus 4, like this. G of 6 is equal to 5, like this. G of 8 is equal to 5, like this, right? G of 4 equal to 5, G of 6 equal to 5, G of 8 equal to 5, like this. Now the common domain of this, the common domain, okay, common, see here, Nana, common domain of f and z is nothing but what you will be having here is this is intersection of domain of f 4, 5, 6 intersection, right? This is what d1, actually d1 intersection d2. d2 is 4, 6, 8, like this. And that is nothing but, this is what d2, that is nothing but we have here 4, 6, like this. This is what common domain of f and z, right? Wonderful. Now we want to find first one, f plus g of, okay, f plus z. Now only we defined that f plus g of x is equal to f of x plus g of x for all x belongs to the common domain, okay, for all x belongs to d1 intersection d2, we told like that. That means now we see, Nana, f plus g of common domain is 4, like 4, 6, like that means f of 4 plus g of 4, we are going to do like this. F of 4 value, f of 4 is what, 5, like this. And g of 4 value is what, minus 4, like this. Okay, 5 plus of minus 4, that become 1, like this we have here. Next, f plus g of 6, like this. F of 6 plus g of 6, like this. F of 6 value is what, minus 4, like this. And g of 6 is what, plus 5, like this. Okay, f of 6 is minus 4, g of 6 is 5, that is also 1. That's all. Now you have got wonderfully. Therefore, f plus g is nothing but f plus g, the elements what you are going to have, 4, 1 and 6, 1, like this, 6, 1. F plus g is nothing but like this we have here, nicely. Wonderful. Next, the second one here, f minus z. In the same way, my dear students, how we are going to do f minus z of x is equal to f of x minus g of x, like that means now f minus z, okay, where x belongs to the common domain, like that means f minus g of 4 equal to f of 4 minus g of 4, like this. F of 4 value is 5, f of 4 value is 5, minus g of 4 is nothing but minus 4, 5 plus 4 is 9, you have here like this. Next, f minus g of 6, that is nothing but f of 6 minus g of 6, like this. F of 6 value is minus 4, minus g of 6 value is minus 5, that is now minus 9, you have here like this. Right, my dear students, f plus g and f minus g, such a beautiful way we have found like this. Next we have 2f plus 4g of x. That is nothing but how we do is now, my dear students, 2 times of f of x plus 4 times of g of x, like this. And here now 2f plus 4g, this is also the common domain, is what 4 comma 6 of first 4 if you take like this. This is 2 times of f of 4 plus 4 times of g of 4, like this you have. 2 times of f of 4. F of 4 is nothing but 5, like this. Plus 4 times of g of 4, that is minus 4. 10 minus 16, that equal to minus 6 you have here, like this. Next 2f plus 4g of, right, 6 you have here, like this. 2f of 6 plus 4g of 6, that is 2 times of f of 6. F of 6 is minus 4 plus 4 times of g of 6. G of 6 is equal to 5, like this. Now this is minus 8 plus 20. That means 12 you will have, like this. Therefore the elements we have here 2f plus 4g is equal to, you have here 4 comma, you have minus 6 and 6 comma 12, like this, right? These are the elements which are present in 2f plus 4g, like this. Now we have here root f of x. This is nothing but square root of f of x for all x belongs to, okay, the domain of f, like for all x belongs to domain of f, like this. Now root f of 4 if you take here, root of f of 4, like this. Square root of f of 4, that is what, square root of 5, like this is what now, root 5 we have here, like this. Now square root of f of 5 if you take, square root of f of 5, like this. F of 5 is what, 6, that is now root 6, right? Fine. Square root of f of now 6 you have here, like this. Square root of f of 6, this is equal to square root of minus 4. This is imaginary quantity, it is not defined. Therefore you have here square root of f is equal to the elements what you have, 4 comma root 5, like this, and another one 5 comma root 6, like this, right? Root f is nothing but like this we have here. Next the ninth one, you have here f square of x, right? Okay, that means f of x whole square. This function is, because we defined f power n of x equal to f of x whole power n, where n is any natural number, like that. Now this way, for all x belongs to, you know that the domain of f, that is nothing but what, 4, 5, 6. 4, 5, 6, this is what domain of f. Now f square of 4, this is now f of 4 whole square, like this. F of 4 whole square. F of 4 whole square means 5 square, this is 25, like 25. F square of 5, like this. This is now f of 5 whole square, like this. F of 5, that is 6 square now. 6 square means 36, like this. F square of 6 now, that is now f of 6 whole square, like this. That is minus 4 square, that is 16 you have, like this. Therefore f square is equal to, my dear students, you have here 4 comma 25 like this, right, and 5 comma 36, right, and 6 comma 16. These are the elements you are having for f square, right. Now we have f cube. Okay, the same way we can do f cube of x is equal to f of x whole cube, where x belongs to the domain of f. Like now f cube of 4 that equal to f of 4 whole cube like this. That is now 5 cube that equal to 125 like this. Now f cube of 5 is equal to f of 5 whole cube like this. F of 5 means 6 cube. That is now, okay, 6 cube, you know, 1 2, okay, 6 cube. This is 6 into 6 into 6. That is 36 into 6. 6 6 is 36. 6 3 is 18 plus 3. 216 like. This is 216. Now f cube of 6 you have here like this. That is nothing but f of 6 whole cube. That is now minus 4 whole cube. Now this become minus 64. Therefore you have here the elements f cube is equal to, right, 4 comma 125. This is now 4 comma 125 and 5 comma 216 like this. Next you have 6 comma minus 64. 6 comma minus 64. Like this beautiful problem can be answered, right. Now see my dear students, we have the fifth problem. If the function f is a function from real numbers to real numbers defined by f of x is equal to 4 power x by 4 power x plus 2, then show that f of 1 minus x is equal to 1 minus f of x, right. How we will do this solution part? We know that f of 1 minus x, if you take here like this, this is wherever x is there you replace by 1 minus x. That means 4 power 1 minus x divided by 4 power 1 minus x plus 2 like this. We have here like this, right. Even we can simplify this also, 4 power 1 into 4 power minus x by this also 4 power 1 into 4 power minus x plus 2 like this. This is now 4 by 4 power x like this, whole by 4 power x plus 2 like this. Now this is 4 by 4 power x whole thing divided by 4 power x. You have here 4 plus 2 into 4 power x like this. This 4 power x will cancel, and you have here like this 4 by this 4 plus 2 into 4 power x like this. This is what f of 1 minus x. Okay, this is what we have the left hand side part. Now you have the right hand side part. If you take here 1 minus f of x, right, if you take 1 minus f of x is what, 4 power x by 4 power x plus 2 like this. Now you take just LCM here. 4 power x plus 2 is the LCM. Like suppose if you take the LCM here like this, right, fine. If we take LCM here, we have 4 power x plus 2 minus 4 power x. That will be cancelled. 2 by 4 power x plus 2. And even the left hand side also we can take 2. We can take 2 common in the denominator. 2 if you take common, this is 2 plus 4 power x by this is 4. Now 2 ones so 2 2's now like this. This is now 2 by 2 plus 4 power x like this, right. Therefore this is what left hand side and this is what right hand side. Therefore left hand side is equal to, you have very nicely the right hand side part, right my dear student. This way you will be doing this particular problem, right. Now we have another basic problem. If f of x equal to 3x minus 2, if x greater than or equal to 3, x square minus 2, if minus 2 lesser than or equal to x lesser than or equal to 2, 2x plus 1 if x less than minus 3. Then they are asking to find number 1 here, of course, f of 3. f of 3 means 3, x greater than or equal to 3. If we have to take this one. That means 3 into 3 minus 2. 3x minus 2. Here x equal to 3. That means 3 into 3 minus 2. In the place of x we have to take 3. 3 into 3 minus 2. 9 minus 2 that equal to 7. f of 3 is this. Next we have here, right, f of z. Okay, fine. f of 3 is that we have here like that. Next what we have is, fine, f of 0, like f of 0, where 0 0 belongs to minus 2 to 2. Therefore this I have to take minus 2 to 2, 0 is there. Therefore, I have to take this function. That means 0 square minus 2, that is now 0 minus 2, that equal to minus 2, like this. Okay, next we have f of 7, like f of 7, 7 when x greater than equal to 3, 7 is greater than equal to 3, I have to take this one now, 3 into 7 minus 2, 21 minus 2, that is now 19, we have here this. Next, f of minus 9, like f of minus 9, x less than minus 3, minus 9 is less than minus 3, that becomes 2 into minus 9 plus 1, minus 18 plus 1, that is now minus 17, like, okay. Next, we have here f of minus 2, here like this, f of minus 2, okay, minus 2 here, minus 2 lesser than or equal to x lesser than or equal to 2, f of minus 2 is nothing but minus 2 square minus 2, like this, 4 minus 2, that is 2, like this. Next, sixth one you have here, right, what, f of minus 7, like this, f of minus 7, right. Minus 7 is less than minus 3, that's why you have here 2 times of minus 7 plus 1, minus 14 plus 1, that is minus 13, like this, right, fine, minus 13, f of minus 7 is minus 13. Next, f of 2.5, like this, right, 2.5 is where, right, f of 2.5, it is defined only x is between minus 2 to 2, x greater than equal to 3, x less than minus 3, but f of 2.5 is not defined here. It is what you have to write, not defined here, of course. 2.5 is not at all defined, right, like this, fine. F of 4, like this, f of 4, x greater than equal to 3, that means 3 into 4 minus 2, you have to take this function, 12 minus 2, that is 10, like this. You will be doing this kind of problems, right. In the next video we are going to do some different problems, domains, like that. Okay, Rana, thank you.